All right. Well, hello, everyone, and welcome back to the show. It is your favorite Jackson, the good Jackson, if you are over on Dapper's show also. So we are continuing with our Croc show, and joining me and our show is not just a croc. It is a legitimate show. That is what we run here. So joining me for that is Nesslig, one of my editors. Welcome back.
Hello, hello.
And we also have Peter, who's here. He is producing for us right now. We may or may not have Dapper. Not sure currently. So, how's your week been?
Well, it's been all right.
Okay, well, fair enough, I guess.
Yeah.
Let's see. We got Triceratops says you should just click harder, and Jake insert clever Dapper inside joke here. Nelson, welcome, guys. Glad to have you back. Okay. All right. So we are
also introducing the other Dutch guy.
Yeah, I said Peter.
Yeah.
I
don't see him.
The other Dutch guy is confined to the back room, Nesslig, because he started a live stream on Jackson's channel, which wasn't at all approved. So for everyone who got the notification and saw a terrible, terrible young Earth creationist for a few seconds, my apologies. That was my fault.
All right.
That's okay. That's all right. So today we are going to be continuing onward with our talk of the evolution of Pseudosuchians.
Yay.
So I'll let Nesslig take it away.
All right. Can you pop up the slide? There, thank you. And can you also make it bigger for all of us as well? Because it will be easier for me to read my notes on the slide. Thank you. All right. So this is where we left off with the Ornithosuchids. And I don't need to repeat what we said about this. So if you want to know more about what we said before, you can consult the other 2-hour hangout. All right. So next slide. So the next group of Pseudosuchians are the Erpetosuchidae, the creeping crocs. And I believe the name has the same root as herpetology as well. So herpetology means the study of creeping things. That's I believe what it refers to.
Is it? Okay.
I think
I've never actually looked up that.
Yeah.
That.
If only we had our resident linguist.
No, you're right. It does mean creeping animal, herpeton.
Yeah.
Are these the same creeping things that are mentioned in the Bible, or are these different creeping things? Because
there are some of the creeping things if you take a young Earth creationist approach.
Yeah, those are creepy things, Jackson.
Oh,
slightly different spelling.
My mistake. I understand.
Yeah, like herpetology includes study of both the non-monophyletic group of reptiles and also amphibians. Of course, reptile in the modern sense, in the cladistic sense, includes birds as well. So yeah, but in any case, about the Erpetosuchids, they are small to mid-sized carnivores. They were lightly built, but were very heavily armored. Like a very, as you can see in his artwork by Nix, you can see like these bony knobs on the legs right there. And they also had the 2 rows of dorsal osteoderms. Like many Pseudosuchians also had those 2 rows of dorsal osteoderms, but Erpetosuchids had more extensive armor around the legs as well. They also had very few teeth, curiously, and those teeth were limited to the front of the upper jaw. The very odd dentition. So they probably ate like small things smaller than themselves, and they were probably preyed on by things much larger than themselves. Hence why the armor, probably. So the exact phylogeny is uncertain about this. They may be outside a group you're going to deal with later on, the Paracrocodylomorpha, or they are sister to the Ornithosuchids, or they are closer to the Paracrocodylomorpha. They hover around a particular place within Pseudosuchia, but there are like slightly different positions within that is debated. All right. Are you familiar with this group, Jackson, or just?
I've heard of them like Erpetosuchidae. Yeah, I've heard of that guy.
Yeah. So unfortunately, not a very popular group because I tried to find like artwork of this, and this is the only artwork I found.
It's really just kind of they're typically just kind of mentioned in the stuff I have seen as just like Pseudosuchians of the Triassic, and that's kind of it.
Yeah,
that's really all they get.
Yeah, and in most slides, I don't show every single species and not even every single genus, because that will be way too much. But here, I believe I am showing every single species that is known to us. So it's not a very extensive group either. So there are like 1, 2, 3, 4, 5, 6, 7-ish genera known to us.
Okay.
Or species also, yeah. All right. Next slide. So here is a very popular group, a very well-known group, even among paleo enthusiasts, the Aetosauriformes, or the Aetosaurs for short. Like technically speaking, the Aetosaurs are like a specific subset of the Aetosauriformes, but I will just say Aetosaur for short. Okay. This is even more extensively armored. They have like a dorsal carapace on the top with paramedian and the lateral layers of armor, and also a ventral armor on the belly side, and also a trunk armor on the bottom of the tail as well. Very, very, very heavily armored. Like they are often compared to the ankylosaurs of among the dinosaurs as well. So they are like a group that is convertedly evolving to become like tanks, basically. Yeah. And let's see here. Also, any other notes I can mention? Oh yeah, look at the one that has like the spikes on the doors on the shoulders. That is, I believe that one is named Desmotazucus. I believe that's the genus of the one that has these dorsal or the shoulder spikes. And I believe also, yeah, go ahead.
There's an event that we have here in Shreveport, which is called Jurassic Quest, and it has like the life-sized dinosaur and also a couple Pseudosuchian like figures, statues, whatever you want to call them. So most of them are like around human size, but it does have like a Tyrannosaurus Rex, and it has, I think it's an Apatosaurus, which is it's really something seeing these like their actual size. It's quite crazy. You don't really realize how big these things are until you see them in person.
Yeah.
But they had Desmotazucus as one of the figures, which I thought was really cool.
Yeah, I also include some like on the left. You see like a few examples of Aetosaurs, and I also include a human, an average human size for scale, the gray out silhouette over there, and you can see that the Desmotazucus with the shoulder spikes is pretty big. Like it's a pretty like a hefty cow-sized animal, basically. Yeah, I would say, or even slightly larger than an average cow. Yeah. It's also interesting about the Aetosaurs. There are like 2 or 3 different forms. Like you have like I don't know if you can see these, but I put some silhouettes at the next to the names of the genera. Like there's one silhouette of from the top view, you can see that there is one silhouette which is called a deep red, which is a very narrow form, And then some genera are very broad. They have like a very broad shield on top. Those are like the orange silhouettes. Like one example is a Typhothorax, named after the very broad thorax build. And then on the bottom you see the blue silhouettes. Those are the ones that have a shoulder spike. So the different forms that have evolved in the Aetosaurs. Basically, like again, very similar to the what was the group again? Combining both Ankylosaurs and the Stegosaurs again.
Thyreophorans.
Thyreophorans, yes. So in Thyreophorans, you had two basic strategies of armor. The passive armor of Ankylosaurs and the active spiky armor of the Stegosaurs. And you more or less have the same thing happening here. Like on one side, you have the very broad shield tanks, and on the other side, you have these spiky forms. Yeah, more active defense versus passive defense. Yeah. So different ways to defend yourself against very dangerous predators. And indeed, as we shall see later, there were some pretty big predators around, even in the Triassic, which were not dinosaurs. They were pseudosuchians. But yeah. And one last final note is that there is like one transitional Aetosauri form called Rufieltosaurus. Like I have the skull in the middle right there. You can see it is an intermediate between a more derived Aetosaur and a more normal-ish skull compared to the Erpetosuchid tardiadia. So yeah, there is like a one transitional form that we have for this. Not as specialized, so perhaps it was not as herbivorous as the most Aetosauri form is, but this one is probably more like omnivorous compared to the Aetosaurs. I believe many Aetosaurs are also general in the diet. They probably ate mostly plants, but all perhaps even many herbivores will eat some
very opportunistic.
Yeah, like you would be surprised that cows can like eat like birds, for example.
Oh yeah, I've seen the videos of the cows just like eating little chicks, and it was like, no.
All right. Yeah, I think that's it for. One last note is the like I again in some groups I put the a figure from Paleo Biodatabase, and you can see their fossil distribution in the image right there. So they are known from like most of them are known from North America. There's a very extensive fossil record from that place, but also a few from Europe, North Africa, as well as South Africa and Argentina. And also a few from India as well. Yeah. All right. And that's it. We can go to the next slide. And some more paleo art from about the Aetosaurs. A few examples here given. Again, this is unlike the Erpetosuchids, this is a very popular group, and there's lots and lots of artwork about them. Yeah. All right. The next slide. So now we come to another rather obscure group of pseudosuchians, the Gracilisuchidae, or the gracile crocs. And again, I'm showing the 5 species known to us. There's actually one species called Gracilisuchus. Let's see if I can pronounce this. Stipanicogorum. I believe I'm pronouncing that not correctly, but
sounds
like
good as any pronunciation.
Yeah, I sometimes I'm also struggling to pronounce these names always. Yeah, but this is one. I think we had a new specimen of. Oh no, sorry, not of this species, but a different species. There's a new genus called Parvosuchus. That's a new genus that was discovered fairly recently in 2024. Parvosuchus. And you can see like on the artwork on the right, You can see Poposauroidea scurrying the scraps of a dicynodont, which is a stem group mammal, like it's our relative, which is like being munched on by a much larger predator called Prestosuchus. So yeah. All right. Any notes that you have on this group, Jackson? Or if you feel free to
No, this
interrupt
is
me whenever
another one that
yeah.
it's just kind of in the books I have. It's just like Triassic Pseudosuchians, and that's just kind of the only. And like they might have, like I've heard of these guys. Like I've seen Gracilisuchidae in some of the books that I have, but they don't get much space usually.
Yeah.
So.
Yeah, they're also very small. As you can see, like I sometimes include like a silhouette of a human in the background. You can see the two legs, the two silhouette legs in behind the like one example. You can see the very small rat-sized animals. Yeah,
that is a big freaking rat.
Yeah, very. Some rats can be pretty big.
If you have rats like that,
yeah.
I would move to a different country.
And they can get quite big, but by Pseudosuchian standards, they are very small. Yeah. Also, I believe Peter has included a comment in the private chat that you can read.
Oh, he's yes, Jake. Yeah, Jake Nelson says, if I'm remembering correctly, Pseudosuchia is false crocodile. Well, that's the funny thing, right? Technically speaking, Pseudosuchia is directly translated as false crocodile, but it includes the Eusuchians, the true crocodiles, as well as their cousins. So yes, it's both. It's things that look, a lot of things that look crocodile-like, but aren't themselves crocodiles, as well as the crocodiles, which is a very fun naming convention there.
Yeah, it's just the case that like these like the groups that we are now currently discussing, they were discovered like many years ago, and back then when the scientists first discovered this, like, oh, they look a bit like crocodiles, but they probably aren't related, so we're just going to call them false crocodiles. But then it turns out later that no, they are related to the crocodiles. Yeah. So, but the name stuck, and that's why we have the it's all the naming convention that we sometimes get from this. All right, next slide. So now we move into a subgroup of pseudosuchians called the Paracrocodylomorpha, which is translates to the alongside the crocodylomorphs. So basically, it includes the crocodylomorphs as well as their some of their closest relatives, and they are defined as the least inclusive clade uniting the Poposauroids and Crocodylomorphs. So the smallest clade you can make while still including both the Poposauroids and the Crocodylomorphs. Basically, this name superseded the traditional taxon called Rausuchia. Rausuchia, sometimes you still hear about the name, the Rausuchids or Rausuchians. But in a traditional sense, that is now currently paraphyletic. Now we think the Rausuchians are the ancestors to the Crocodylomorphs. Like we used to think, again, same with the same discussion as the Pseudosuchians before. We used to think that the Pseudosuchians were not related to the crocodilians, but it turns out they are. And now the same thing happened with the Rausuchians. It turns out the Rausuchians are the ancestors to the Crocodylomorphs. Yeah. There are some traits that typifies this group, like the tip of the pubis. It has been expanded, called a pubic boot. And the length of metatarsal 2 is as long or longer than the length of metatarsal 4. The ilium is positioned in a way such that the hip socket points downwards. So now you have a pillar erect stance. Like just to call back from the previous part that we did last week, we mentioned that like the Archosauriformes are characterized by a sprawling gait, but now we see that the the gait has become fully erect or pillar erect. Not the same thing that happened in the dinosaurs. The dinosaurs have an interned hip socket. Basically, the head of the femur points 90 degrees relative to the rest of the femur. But in Rauisuchians, or in this case the new name Paracrocodylomorphs, the ilium itself is like expanded outwards, such that the head of the femur still points directly up, but then into the hip socket directly like that. You can also see the image right there, the schematic image on the bottom right. That's the configuration of the pelvis with relative to the femurs. And you can see that there's a very big difference between that configuration relative to the configuration seen in the dinosaurs and also the mammals as well. Mm-hmm. All right, next slide. So this is like one very, very neat group called the Poposauroids. Also, I would like to call them dinosaur mimics, but they are named after a particular formation for which the first complete material of Poposaurus was first described. So yeah. But I would call them, if I would call them dinosaur mimoids. Because they are so much like dinosaurs. Like many of them, yeah. I believe many of them were confused for dinosaurs in the past. Like you had, Poposaurus was first called a dinosaur because they basically, like some of them became bipedal, like almost like a theropod, basically, like Poposaurus, and they also evolved like a cell. Like one of them is called the Arizinosaurus, which has a cell back. Very interesting. And you also had a gigantic biped called Shuvosaurus. Although I think there's a debate on exactly how big this specimen was. Like there are some size estimates of Shuvosaurus, but I believe some size estimates get them to be very, very big, almost as big. Like you can see the silhouette right there next to the gigantic. Like you can see on top of the globe image or the map image of the continents. That one is Shuvosaurus, the big one, and you can see a silhouette of human on scale on the right, above the name Credit Nix. So it's a very, very large size. Again, some may disagree on exactly how big this was, but still interesting to see that this biped, a Pseudosuchian, a crocodilian relative that was bipedal and gigantic like that. Very interesting.
That is quite interesting.
Yeah. So all other notes, most had long necks in this group. Some, as I mentioned, some were bipedal. And they also, interestingly, they convertedly evolved a perforated acetabulum, although in a very different way. You can see some images of a pelvis, like on the left, you have an example of a dinosaur pelvis with the open acetabulum or an open hip socket right in between the ilium, pubis, and ischium. But in the Poposauroids, what happened was the pubis disconnected from the ischium. So it is the hip socket is open, but it's open in a very different way compared to the dinosaurs.
I want to throw one little bit of trivia in here, since you mentioned the Arizonosaurus. So as Nesslig mentioned, so they have that sail. Of course, our synapsid lineage evolved its own sail. As the Dimetrodon and Edaphosaurus, they had their own sail, and Sphenacodon and those other early synapsids. Of course, dinosaurs, Spinosaurus, and an amphibian also did that. A little guy called Platyhystrix.
Yes,
evolved the sail. So
yeah, and I believe the only only thing that is close to that is like a salamander that still lives today. That's the only thing that we still have. Is or I think also a few lizards with like cells, right? A few lizards. Or cats.
Yeah, I
They
think
have cats. Yeah.
the basilisk lizard is one.
Yeah.
There's not a whole. I don't think there. Yeah, the little basilisk lizard. I can't really think of any others offhand.
Yeah. There are many like I don't believe the basilisk has like I think the Erpetosuchidae has these bones from the dorsal vertebrae, right? Like the neural spines going up into the cell, right?
Yeah, it looks like these guys can put their sail like up and down. It looks like so.
Yeah, but the basilisk doesn't have bones in the But Erpetosuchidae and also of course Spinosaurus did have the neural spines all the way in the cell. So yeah, it's very interesting that this trait has evolved so many times, and yet we don't have something like this anymore. Yeah,
there you go. I put Platyhystrix down there on the side for anybody who wants to look him up.
Yeah.
Oh, I misspelled it. That's okay. It'll fix it for you.
Google can handle it.
Yep.
All right. Next slide. So a new subgroup of pseudosuchians within the Paracrocodylomorpha. You have a group called the Loricata. Basically, this group includes some of the apex predators of the Triassic, like like before in a very long time ago. This group was named Crocodilia, but now the current definition of Crocodilia is now the crown group of crocodilians, which is again, we defined that in the previous part, but I can define it again. The crown group is basically the last common ancestor of all crocodilians and all its descendants, and that crown group is much younger than the Loricata group. But yeah. So but this group is defined as the most inclusive clade for crocodilians, but excluding the Poposauroids and also the Ornithosuchids, Ornithosuchus and Aetosaurus. So that's the definition of this group, the Loricata. And some early members of this group. Oh, do you have a comment? I heard something in the background, so I thought you.
Oh, that was my beautiful wife opening a soda.
No worries.
I didn't realize you picked that up. That's pretty crazy.
No worries.
I just want to say, if I were to make a comment, hypothetically, I would say that I have watched the BBC's Walking with Dinosaurs many times. And the first episode features Poposauroidea,
yes,
which is pretty cool.
Yeah, but it's not a dinosaur. And I believe the Walking with Dinosaurs it also made it clear as well. It is not a dinosaur.
No, they point out it's a crocodile relative. Because you see it basically followed the first episode because it's the Chinley Formation, I believe. Follows like some Coelophysis, Poposauroidea, Placarius, which is a dicynodont. So that's the anomodonts, one of the few groups of synapsids to make it through the Permian extinction. And then I think like Plateosaurus shows up like at the very end of the episode. But anyway.
Yeah. Go watch the.
Yes.
If you haven't,
watch all
watch
of them.
The Walking. The CGI may be a bit outdated, but I still think it's a gem to watch.
Oh yeah, they're great.
Nonetheless, yeah.
I can't really think of any others. Well, I mean, there was a one that those like did a really good job of being both in depth, like and covering quite a bit of different different locations where we find dinosaurs. So like it jumps around to a bunch of different very well known fossil sites. Which there was I think it was called Life on Our Planet. It was narrated by Morgan Freeman, came out like last year, year before last. It was decent. It was fine. It covers that one, for anyone who is not aware, that one covers more kind of like life generally, from like the start of life up to today, which it was fine.
I found it a mixed bag. Like I think the like the CGI thing was pretty good, but I think the way like the dialogue was pretty could be better. Like like Morgan Freeman was like, oh, the dynasty of these animals, like just talk about them as if they are real animals, not like like we tend to think like, oh, these rule the earth at some point, but just describe them as animals.
I think
I like it.
I think that's fair. My favorite thing about it though was it showed a couple little like tetrapodomorphs kind of sprawling on land, and I don't think I've ever seen. I think that might be the first time I've ever seen a show like animate tetrapodomorphs doing that, really. In that manner, I don't think I've ever seen any other ones do that. And I thought it was really well done. I thought it was pretty cool.
Yeah.
So
I also like the bloopers with Morgan Freeman. Like he reacted to a I believe like a an extinct fish called Secambambis, or
Secambambaspis or whatever, something like that.
Yes, Secambambaspis, yes. And Morgan Freeman was like, he just was cracking and laughing about. Look at this guy.
They look like, pretty goofy. They have like little tiny face. Yeah. They're very. I think they were even like a meme for a little bit, because they're just. He's like the little face is like, wait, what happened? Yeah.
It's funny that Morgan Freeman was like all cracked up by. Yeah,
I'll put it here in the side chat for anybody. You guys need to go look this guy up, because like the photos of him are hilarious. His little face.
Yeah, Secambambaspis, yes. A goofy name for a goofy fish.
Yeah, he was very surprised by everything he saw.
Shocked, I say, shocked. All right, so going back to the slide. This group, like the early members of this group, included some of the largest terrestrial predators that ever lived. The largest land-walking predators. The only ones that outsized them were the theropod dinosaurs, but shh, we are not talking about them today. We are talking about the Pseudosuchians. And some traits that I can mention that signifies this group is they have like a very narrow orbit, or an eye socket, as you can see here. You can see on the left a Poposauroidea compared to a Poposauroid on the right, and the Poposauroidea has a very narrow orbit compared to highlighted in yellow. The orbit is highlighted in yellow. In Poposauroidea, it is very narrow compared to the Poposauroid. All right. They also have other traits, a rich attachment point for the iliofibularis muscle, halfway down the length of the fibula or shin bone. So they have a different muscle in the leg that is very powerful, apparently. Probably because they are very large, and they use this extra strength in the legs to like hunt down prey. I would guess, at least. All right. Let's see here. Oh, so one thing to mention is that if one group called the Prestosuchidae, the family of Prestosuchus, but that is paraphyletic, according to this phylogeny that I'm showing right now. All right. That's it for now. Going to the next slide. Yeah. And this is like, well, this is arguably the largest. I believe it's the contender of the largest Pseudosuchian, or at least the largest land-walking Pseudosuchians. We will see some Pseudosuchians that are probably much larger, but they were not land-walking. They were like semi-aquatic. But this is like the fully terrestrial, the largest fully terrestrial Pseudosuchians compared to an early relative of the sauropods, Lesamsaurus. And you can also see a human silhouette for scale. Very, very big land predators. And are you familiar with the Fasolasuchus.
Uh,
Fasolasuchus. Yeah.
I've heard of this one. I'm like
Mhm.
vaguely familiar with the Prestasuchids. I mean, like aside from I'm just kind of generally aware of them as a result of the like Postasuchus, but the rest are just kind of I've heard of them.
Yeah. All right. Next slide. So, like we've now covered almost the entire Triassic, but I also want to mention some of the significant biotic turnovers that happened at the start of the Triassic, and also in one in the middle, and then one at the end of the Triassic. So, as you all may know, the Triassic started with the worst mass extinction that the Earth has ever experienced. Over 95% of marine animals and over 70% of terrestrial species were wiped out in the Permian Triassic mass extinction, or also called the End Permian extinction event. And I believe that there is. I haven't seen much debate on this. I think it's pretty much consensus that the cause of this extinction event was the massive flood basalt eruptions in
That's
the
pretty much what I've
Siberian
seen.
steppes. Yeah.
I mean, like I've seen some additional stuff that's like the extra like nickel and sulfur that was present in the environment allowed for archaeans to develop more in areas, and grow and spread out in areas where they weren't able to previously, which might have helped with their evolution and blah blah blah. But like, yeah, pretty much it was
What group? Sorry, can you repeat it? Archaeans?
Nathanosarcina, I believe, was one of them. I bet I can find that paper.
You mean the like the not bacteria but the archaea, or
Yeah, I said archaea. Yeah.
oh yeah, oh
So this guy right here. Oh, here, hold on. I'll put it here in our side chat. Nathanosarcina or Sarcina, however you pronounce that. I do not know. Boop, there you go.
Yeah.
But basically, yes, you're right. I've not seen really anybody arguing that it's anything really other than the basaltic, the igneous provinces essentially that caused massive volcanism. That's pretty much what I've seen. So
it's pretty bad. Like basically, it was not your typical like you probably have seen the eruptions in like Iceland, where you can see these pillars of lava just spewing out from in a crack from the earth, and this basically was like the size of the United States, pretty much. Yeah.
which is an important point, right? Because what a lot of people don't understand, like you get a lot of climate change deniers, for instance, and people who are just genuinely curious. It's not always the deniers, but a lot of people ask, like, hey, how do we know that climate change isn't being caused by volcanism? And the answer is it can be if there's a lot of volcanism kind of consistently that is occurring. So this event took place over the course of 2 million years, right? You had 2 million years of this of these igneous provinces.
Probably not a constant eruption, maybe impulses or so.
Right. But
pretty much 2 million years. Pretty much.
But yeah, this area the size of the U.S. for putting out pulses of like volcanic activity over 2 million years, resulting in the massive heating of the earth. And that's just we don't see anything like that today. There's nothing on Earth like that right now. So
and there are also other confounding factors, like on Iceland, where you have these eruptions. You don't like there is just lava there, and also as a basaltic rock. But as it just happened, the Siberian traps were like on top of a coal bed. So basically, this eruption ignited a huge section of coal that was buried in the ground. So they were, in a sense, burning fossil fuels, as you.
Right, isn't that funny? Even the volcanoes were burning fossil fuels, which was contributing to climate change. Right? It's always that.
There are also other things as well. I believe that there were also like salt deposits in the area, which basically meant that like when you heat up salt to such an extent, you produce chloric gas,
Mm-hmm.
and then I can produce acidic rain from that
Right.
as well. And I can also block sunlight and damage the ozone layer as well.
No, that's also
Sounds an
fake.
awful. Sounds an
Don't you know
awful.
that
An awful. Yeah.
there was no hole in the ozone layer? There's no acid rain. None of that's real. Don't worry about that. Sorry.
Yeah.
Anyway, go ahead.
No worries. I also believe we have like pollen grains, which show deformities associated with exposure to UV light as well. So yeah, so you have probably many different things that went very wrong during this, and not just incredible climate change, but also acidic rain, damaging the ozone layers. And I believe the oceans became euxinic. They became low in oxygen and
Right.
high in sulfur,
Mm-hmm.
hydrogen sulfide and such. Yeah, so everything was choking to that, especially in the ocean. Hence why the ocean got hit the hardest. Like, almost everything died in the ocean. Over 95%.
95%. Yeah, that's pretty bananas.
Yeah.
That's a pretty bananas number.
Mm-hmm. But to move on, in the after the extinction event, in the early Triassic, the diversity was still low, and the diversity was still dominated by the stem mammals. Like the stem mammals dominated before in the end Permian. The stem mammals dominated, and they still dominated in the early Triassic, but they quickly were superseded by the Archosauromorphs when they radiated and gained dominance in the ecology, and especially as top carnivores. All right, next slide. And then next, in around the middle of the Triassic, you have another significant event, not a mass extinction, but still significant. It's called the Carnian Pluvial episode, which is a period when the global climate changed or switched before it was dry, and during the Carnian Pluvial episode, it became very humid, and then after the episode ended, it became dry again. So you have like a short period of very humid conditions. Like, it's often said that this is the time when it rained for a million years, but no, it probably didn't rain constantly. It was just a very humid period.
Right, like more like the tropics, but like more widespread.
Yeah, imagine the difference between a tropical environment versus a savanna environment, basically.
Right.
Yeah.
Which when I lived in Baton Rouge, which is not, I mean, it's closer to the equator, I guess, than Shreveport, but the feeling of like rain every single day or like a mist every single day, I hated it. I like did not like it, did not enjoy it, could not live in the tropics.
Yeah. I'm also not very keen to very hot conditions. Like, if you ask me, I rather live in a very cold environment compared to like a very humid. I cannot stand humidity. I
don't mind humidity because I mean that's, I live in Louisiana, but I'm not a big fan of the cold. So.
All right. But during this period, like unlike the Permian extinction event, the cause of the Carnian Pluvial episode is not very clear. Like, some say those volcanic eruptions that triggered this humid period, or maybe like a formation of a new mountain range that can cause, like, I believe the Himalayas is responsible for why India has like a monsoon season, because when you have like a very humid air colliding with the mountain range, that can cause very significant downpours as well. Yeah, so maybe a new mountain range. Regardless, this event is associated with the extinction of ancient plant groups, but also extensive radiations of modern families of ferns, conifers. This is also where we find the oldest amber fossils after this event. So yeah, now we have amber fossils from this. And you also, correspondingly, you also have a significant change in the composition of herbivores. Like, this is where you have the Rhynchosaurs, which you previously mentioned in the episode last week. You also have like a last surviving lineage of stem mammals called the Dicynodonts. They were still lingering on after the extinction event. But they became very rare after the Carnian Pluvial episode. And there's also when the dinosaurs, and especially the Pseudosuchians, dominated the ecology because of this. This is when the Earth switched over from a stem mammal dominated ecosystem to a Archosaur dominated ecosystem, especially among the herbivore side. All right, next slide. And then after the Triassic had ended, it ended also with a mass extinction event. So this one was not as bad as the Permian extinction event, but it was still pretty big. Like it killed between 70 to 80% of all species. This one, I think it's less certain compared to the Permian extinction event, but the most common explanation I've seen is the CAMP, the Central Atlantic Magmatic Province. I believe that's the acronym for CAMP.
Yeah, that's what I've seen mostly too. So
it's also a flood basalt eruption, but this one occurred right around the point where the Atlantic Ocean started to form between North America and Europe and Africa as well. Yeah. So this was the event that basically ripped the continent apart almost. Of course, it didn't physically push it apart, of course, but it was like it was more like the continents started to move apart, and then that also opened up the flood eruptions as well. Yeah. All right. During this event, what you have was tall trees tended to survive better than short trees. So this is when you have like high browsers, like the sauropods. They survived pretty well during this environment. They didn't really experience a very big extinction during this time. And dinosaurs in general did pretty good, but the Pseudosuchians were hit pretty hard. Like there was only one surviving group, the Crocodylomorphs, survived this extinction event, and all the other Pseudosuchians died out. All right. Any comments on this, Jackson? Or
I don't think so.
All right. Next slide.
I'm still on board.
So yeah, so the survivors of the Triassic, the Crocodylomorphs, they were unlike before I mentioned the very big predators like Poposauroidea and such, but the Crocodylomorphs were mostly small to medium-sized, and they were also unlike the other Pseudosuchians. They were slow-growing. I've seen like a few papers that discuss the osteohistology, where you can see signs of growth in the bones, and it turns out that Crocodylomorphs probably were very slow-growing animals, and they also stayed very small. So maybe this is one reason why they managed to survive the extinction event, unlike the fast-growing relatives. So yeah. Also, like there's one old taxon called the Spinosuchians. This is a paraphyletic group of early crocodylomorphs. So yeah. So basically, early crocodylomorphs are Spinosuchians, but that's a paraphyletic. So some Spinosuchians are more closely related to later members of crocodylomorphs called Crocodyliformes than they were to other Spinosuchians. All right. And one daughter, I've seen a paper which proposes the daughter clade Solidocrania, which includes the Crocodyliformes, and they are characterized by several features which reinforce and solidify the skull. So they have very robust skulls in this group. And this taxon was proposed by a paper authored by Rubenstahl et al. And I believe I wished that Dapper was here, because if I remember correctly, he talked to Alex Rubenstahl many years ago, many years ago, like 8 years ago, I believe. And I think this is the same guy who authored this study in 2022.
Oh, maybe, I don't know.
Yeah, maybe it's a very peculiar name. So I was like, hey, wait, Rubenstahl? Didn't Dapper talk to a guy named Rubenstahl many years ago? So Dapper, if you're seeing this, please tell me if this is the same guy or not. So yeah, I would like to know. All right. Next slide. So now we are going to a subset, as I mentioned before. The subset of Crocodylomorpha are the Crocodylomorpha, which this is one that was very diverse. An underestimated diversity post-Triassic. Like, many people tend to think that crocodiles or crocodilians were more or less the same in the time of the dinosaurs as they were today, but now we will see many different forms aside from the typical semi-aquatic form. And some traits that typify the Crocodylomorpha are they have also some Sphenosuchians also have this trait. They have they lacked the phalanges on pedal digit 5. So you probably have noticed that the crocodilians only have like 4 clawed toes, basically. And this is where that trait appeared. They lost pretty much almost the entire 5th toe on their legs at this point. And crocodilians still have that, of course. And crocodylomorphs also evolved a perforated acetabulum and fully erect stance as well. So another convergent evolution with the dinosaurs. Although there's differences between that and the dinosaurs. The dinosaurs also have an open acetabulum, but they have it open in a different way than the crocodylomorphs have. They also and modern crocodilians also narrowed down their foramen of the opening in their hip socket. But the opening is almost still there, which allowed modern crocodilians to do a high walk. Like you mostly see them sprawling with their limbs held from side to side, but sometimes you see them walking upright almost. A high walk, it's called. And I believe you have like one very famous video of an alligator just lumbering around a golf course. I think you've seen it too, right, Jackson?
Yep.
Yeah, that's the high walk. Yeah. So they can use
the only good use of a golf course.
Yes. I hate golf. But yeah, this hip socket allowed them to do 2 modes of locomotion. Yeah. But one trait that typifies the Crocodylomorpha specifically is the pubis is mobile. The pubis lost the connection with the ilium or the blades of the hip. So you can see them also. You can see also the schematics on the bottom right there. You can see that on the left you see a pelvis called from Erpetosuchidae with a pretty normal configuration. All 3 hip bones make contact. Then you see the Gracilisuchidae, again still contact. But then in Ornithosuchidae, like one early member of the Crocodylomorpha, the pubis does not contact the ilium anymore. It only contacts the ischium, and it becomes mobile. And it's also probably like this is a probable indication of the origin of a unique way that crocodilians breathe. They breathe by a mechanism called the hepatic piston mechanism. They use their liver as a diaphragm. Like we have a diaphragm, but only mammals have a diaphragm. But crocodilians use their liver in the same way to push and pull against the lungs. And if I may ask you, Peter, can you quickly alternate between this slide and the next slide, and then go back again? Just alternate between the two. Go back and forth, yeah, like that. That's it works. It works.
I like
So
it.
that's the way how they use the mobile pubis to pull and push against the liver, so they can expand and contract their lungs.
That's pretty cool. I'm a fan of that. I enjoy it.
All right. So any notes that you have or questions that you have, Jackson, about this?
Oh, I have many questions, just not really relevant here. I like it.
All right.
I think that's quite neat.
All right. I think we covered everything from this, so we can go to the next slide. All right. So one early diverging group are often called the Poposauroideans, although again this is another paraphyletic group. Members tend to be, in this case, even smaller than the Sphenosuchians, that we mentioned it before. So it's almost like the crocodylomorphs were downsizing in a way. The trend was going to smaller body sizes. Of course, not always. We will see some groups that did the very opposite, of course. So in this case, you have 3 groups called the Notosuchia, Gobiasuchidae, and Erpetosuchidae. And the last group, they are members. They are more closely related to the crocodilians under the clade Mesoeucrocodilia, which are characterized by a fused frontals and a secondary palate. So that group is much closer to the monocrocodilians. More on that later. But the Gobiasuchids are closer to the Mesoeucrocodilia than the Protosuchidae, as shown on the left. So you can see 3 groups highlighted in yellow on the left. You can see those are the Protosuchians. They don't form one single group. They are like scattered around at the early diverging lineages at the base of Crocodylomorpha. Yeah. Also, there you can see also some paleo biodatabase images on the bottom left regarding the continental distributions. And you can see some, they weren't very widespread, but they were still found, like in the Triassic, they were found in North America and South America. And in the middle of the Triassic, they were found on both the northern continents and the southern continents. And then in the Cretaceous, some of them lasted in the Eurasian continent after the continent split apart. All right, next slide. So this is the earliest divergent member or group of the Crocodylomorpha, the Notosuchia, which translates to southern crocs. So according to Martinez et al. 2018, Protosuchidae is the only basal lineage of Crocodylomorphs, and Ornithosuchus is part of the next most basal lineage. However, a more recent paper by Dolman et al. 2021, they identified Notosuchia, which was previously considered a Sphenosuchian, as a close relative of Ornithosuchus and united them under the family Notosuchidae, which is sister to Poposauroidea. So there's a different placement of the phylogeny. So according to the most recent paper, we now have Notosuchia as the most as the one group that diverged from the rest of Crocodylomorpha. And you have a few members like Poposauroidea, again also very, very small, a shoe-sized crocodylomorph, not very big. All right, next slide. Some members managed to linger on for a very long time. You have this one, the last surviving member, called let's see here, Aetosaur. Yes, that's Aetosaur. Which also curiously is likely herbivorous. They have heterodont teeth with cusps, almost like mammals. So very interesting.
That
So
is
like
pretty interesting.
yeah. So maybe maybe herbivorous or more likely omnivorous. Again, I wouldn't be surprised if this one also went after like mammals, for example, or something. But yeah. All right. Next slide. And then another group of early diverging Crocodylomorpha are the Gobiosuchidae, crocs from the Gobi Desert, as they are named after. Only 3 described species from Eurasia, and they, like, according to their phylogeny, they diverged very early on among Crocodylomorpha, but we don't have any fossils from the Jurassic.
Interesting.
They are only
okay.
known, they are only known from the Cretaceous, so they have like a long ghost lineage during the Jurassic, which can happen. So there is some missing record from these, but still, for what we have, they are very, very extensively armored, having quite, even for their size, they have very large osteoderms on their bodies. So yeah, so they probably were being preyed on by other by dinosaurs, for example. So one of the defense was being small, fast, and also armored. I wouldn't be surprised if they were like armadillos, basically, like using their armor and being quick on their feet and scurrying away from the scary big dinosaurs. Yeah. All right, next slide. They also, like as I mentioned before, they were heavily armored, but their skulls were even more solid compared to the early members of the Crocodylomorpha. They have like fused, like the dermal bones were fused on their eye ridges. Like they had like osteoderms fused to their eye ridges. They also closed their, like one trait among reptiles is they have like an upper and like a upper supratemporal fenestrae and an infratemporal fenestra. So a hole like behind the eye socket, you have 2 holes, one upper hole and one lower hole. But in this case, they closed the upper hole and they almost closed the lower hole. So you can still see a very small hole or for the infratemporal fenestra right there. So they have a very, very solidified skull in this case. So yeah. So we mentioned that the holes in the skull among the diapsids can later be lost, and they have lost many times. Turtles is believed to be like I did a video about them a long time ago about turtles.
Yeah. Way back.
We discussed. Yeah, and we discussed. Oh, are they anapsids or are they diapsids? And it now pretty much is consensus that they were diapsids, but they have lost the 2 holes that typified the diapsid skull, and the same thing happened here almost. Yeah. All right, next slide. All right, need a quick drink.
Good gravy.
Mm-hmm.
What a name.
Yeah, Erpetosuchidae.
They're not pulling any punches on the names.
Yeah. So the last group of the Poposauroidea, paraphyletic group. So another. This is an early, as I mentioned before, an early divergent lineages of the Mesoeucrocodilians, which evolved a secondary palate. And crocodilians still also today have a secondary palate as well. The palate in some some Erpetosuchidae also evolved similar configurations seen in the Eusouchians, which is basically the choana, or the internal nasal openings. Like you have external nasal openings, but inside your throat, your nose ends in the choana. And here in the Erpetosuchidae, they have a similar position compared to the Eusuchians as well. Also, Shartocosuchus also lost the end orbital fenestra, so the hole in front of the eye sockets. Again, another way how they have solidified their skulls. Also, a enigmatic genus uniquely had a tibia much longer than the femur. So it's a very unique leg bone. Like normally the femur is much larger than the tibia, but now in this group the tibia is much longer than the femur. But this one has a very uncertain phylogeny. They may not be members of this group. They are either related to the Shartocosuchoids or they are related to the Notosuchians, which would be less surprising regarding their paleobiogeography. So, like one thing to note is that the Shartocosuchoids are mostly known from the northern continents, but this one member, hopefully I can like pronouncing it, Nuquensuchus. Yes, this genus is known from South America, and if this is a Notosuchian, then it would make more sense because Notosuchians were mostly known from the southern continents. Yeah. All right. Next slide. Oh, here is one of my favorites. Yay! This is what I call maybe not as famous as the dinosaurs, of course, but I think many paleo enthusiasts have heard about the marine crocs from the sea. This group includes semi to fully aquatic crocodylomorphs. Most of them were marine, but we also have a few of them found in freshwater deposits as well. There is a big controversy regarding their phylogenic position among the crocodylomorphs. And one main reason for this debate is that they have a very highly derived morphology. So particularly what happens or often happens in the crocodylomorphs is that you have the elongation of the skull. So it's often called the longirostrine condition. So you have a long and a very narrow snout skull. And this trait has evolved many times among the crocodylomorphs. So what can happen is the phylogenetic studies can be confounded by homoplasies. And so there are three main hypotheses regarding the position. So again, you can see them. I put a phylogeny on the left with 3 different positions among the crocodylomorphs. So position number 1 is sister to the Crocodylformes, which is argued by some papers. And the second position is among a sister or as an early diverging member of the Mesoeucrocodilians. Again, some citations that argue for this position. And the third option is that they are sister to the Tetisuchians. And the Tetisuchians is also a group of also includes some marine crocodylomorphs as well. But that last position can also be due to convergent evolution because again, Tetisuchians also include marine forms, so they may be an instance of convergent evolution in this case. But yeah. All right, next slide. But then recently, in 2 years ago, or almost 2 years ago, a new genus was described, Turnersuchus. It is the oldest and the earliest divergent member of the Aetosuchians. So one thing to note is that very derived morphologies can erase the evolutionary past. Like again, one example that we mentioned before about the turtles, like modern turtles don't have the holes in the skull that typifies the diapsid. So they have lost that trait that their ancestors used to have. So with a very derived morphology that can erase these traits they have lost. But in this case, we have an early member which shows some primitive and derived features which can help us better understand the position of Thalattosuchians. All right, so next slide. So using this genus, you have a study by Wilberg et al. And they used 2 morphological datasets to conduct their analysis. And each of these datasets agreed that Tornosuchus is the most basal genus within Thalattosuchians, but they still unfortunately they still disagreed on the placement of the Thalattosuchians among crocodylomorphs. So according to one dataset, which used let's see here, Wilberg et al. 2019. This dataset includes 105 operational taxonomic units, or OTUs, and 410 characters in this dataset. So according to this dataset, they placed the Thalattosuchians as sister to the Crocodyliformes. So a very early divergent lineage among the crocodylomorphs. But the second dataset by Herrera et al. 2021, which used more taxa and more characters, and they put and this dataset puts the Thalattosuchians in a more derived position next or within the Mesoeucrocodilians. So not as ancient as the previous position. So if I were to make a bet, I would go with the second option, because that dataset includes more data basically. But that's just my uneducated guess. So I'm still pretty curious if we see future studies that are more consistent on exactly where the Thalattosuchians belong within the crocodylomorphs.
Okay.
Yeah. All right. So next slide. So regardless of what the position, now just talking about the Thalattosuchians themselves. So the oldest Thalattosuchians are from Europe, although we do have some uncertain early records from like the South America, and also one from I believe Africa as well. But the earliest certain records are from Europe, at the shores of an ancient ocean called the Tethys. So right now the Tethys is gone. It has been replaced by the Mediterranean and the Indian Ocean, and also the Caspian Sea is also a remnant, and the Black Sea as well, if I believe. Those are remnants of the Tethys Ocean. Yeah.
Okay.
But during this time, that's where during this oceanic environment, that's where the early Thalattosuchians are from. And again, during this time, the Europe was an archipelago, a group of islands with the shallow, warm seas surrounding the islands. So yeah, a pretty good place for being a marine reptile. Yeah. All right, next slide. So so now we move on to the later in the Jurassic. We have the splitting of the northern continent from the southern supercontinent. So now we have, like before, we had Pangaea, which is now being split apart into 2 supercontinents, the northern Laurasia and the southern Gondwana. And now we have something we don't have anymore. We have now an equatorial circumglobal current. So we have like one oceanic current that goes all the way across the equator. This doesn't happen anymore because we have like a continents standing.
There's a couple continents in the way. Yeah. Just a little bit of land.
Yeah. So like one good example is like the North and South America. Like they block a current which cause the current to be directed towards the North Pole, and that current is called the Gulf Stream. And that's a pretty significant effect because the Gulf Stream is responsible for why like Western Europe is very temperate compared to what you would expect otherwise. Without the Gulf Stream, West Europe would be very, very cold. Yeah. But here we have a global current at the equator. So we have this current does not reach the poles, so it stays warm consistently. So one thing that happens is when you have like a very warm sea like this, what happens? The sea expands, so you have an increase in sea level, and you also have like a significant loss of carbon dioxide from the ocean as well. So this is also the point where you have significant rises in sea level and also significant rises in temperatures. Like during the Cretaceous, the Earth was very, very, very warm and humid. And this is probably one reason why this is the case. And this is also where the Teletasuchians diversity and distribution peaked as well, which makes sense. Where you have like very warm and you very like warm seas coming all over the world. In this case, connecting many different places all at once. Very, very easy to disperse from this point. Yeah. All right. Next slide. So one, you have the Teletasuchians splits into two groups. You like first you the Metriorhynchoidea and also the Teleosauroidea. But here we are first dealing with the Teleosauroids, which includes only two families. You have the Teleosaurids and the Machimosaurids as well. So the first group, the Teleosaurids, were generally gracile fish eaters. And you have also two freshwater specimens described. Like one was described as a dubious genus called Poposauroidea. I've also seen them called the Chinese Teleosaur. This one is not very well described, basically. So it's a very dubious genus name. But curiously, this specimen was found in the I don't want to butcher this name, the Yujing Formation, which is a deposit that was formed by a gigantic lake, which has been estimated to be 3 times the size of Lake Superior. Like one of the largest lakes that ever existed.
Makes sense why he was why I had crocodiles then, you know.
Yeah. And these were these were still semi-terrestrial, so they were still able to go up to land, but they probably spent a very significant time in the ocean as well. Like there were semi-terrestrial generalists like Teleosauridae, and also some pelagic open sea inhabitants like the Aelodontines. And then in the next family, the Machimosauridae, these were robust macropredatory. So early members of this were narrow-snouted generalists, but later members were more medium-snouted specialists. But within a very specific tribe called the Machimosauridae, they were macrophagous. They probably preyed on large prey, and also some of them also show evidence of being durophagous, probably eating on like ammonites, perhaps, like hard-shelled animals. All right.
Okay.
All right. Next slide. And here's one good example of a.
That's a big boy.
Yeah, Macrospondylus. One very good example of a member. Next slide. And even like well, Macrospondylus. Again, they were still semi-aquatic. These were still able to go up onto land. Probably not very often, but still able to walk. All right, next slide. So now we move on to the other side. Like in the previous slide, we showed them like one half of the Teletasuchians, but this is the second half. The Metriorhynchoids. And all of them, or at least the family of Metriorhynchids, were fully aquatic with flippers, flukes, and smooth skin. There's like a debate on whether they ever left the sea at all. If they left the sea, they probably only left the sea for reproduction.
Right, kind of
Yeah.
being like little like seals or something essentially.
Yeah, or turtles. Yeah.
Yeah.
Yeah. But like we have no evidence of them laying eggs, or also no evidence of them giving live birth. We don't know if they still laid eggs or not. If they did not, if they gave birth live, like mammals or like dolphins and such, or even if they did that, they are the only archosaurs known that did not lay eggs. If that is the case, but again, we don't know for sure. If they did not lay eggs, then they are the only archosaurs that did not lay eggs. It would be very, very unique. And you also have like a study from 2024, which looks at the vestibular organ, or the organ that senses balance, which shows the same adaptations that we see in whales or cetaceans. So they were probably very, very similar to whales in this regard, in how they moved through the water. Like if you are doing pretty violent turns and flips on the water, then it can get pretty disoriented from your vestibular organ. So there are some adaptations that whales have undergone, so to prevent them from going dizzy by making these underwater acrobatic movements. Mm-hmm.
Okay, that makes sense.
Yeah. All right. Also, like one specific subfamily called the Metriorhynchines. They were smaller with slender snout, so they probably fed on fish mostly. But a different subfamily called the Geosaurines. They likely went after much larger prey. They were very robust with very large teeth. And they, like one example is the Dacosaurus and Agiosaurus. And they also had serrated teeth. So they probably hunted like marine reptiles or other marine reptiles, like the Ichthyosaur that you see there. Mm-hmm. So they were pretty much like you would be forgiven to mistake them for mosasaurs, basically. That like there's they also had tailed flukes and flippers. So yeah, if you show them this picture on the right, you would say, oh, that's a mosasaur. No, it's actually a crocodile relative. Yeah. All right, next slide. So some paleo art on the Metriorhynchoids. So yeah, pretty like, well, I believe this one. I think I would say this is my favorite crocodilian relative. Yeah,
they're pretty cool looking.
These guys. Yeah. Somebody says unrelated to marine reptiles. I'm not sure. I'm not sure what you mean. DM Carl Ipsum Wing.
I mean, these are marine reptiles.
These are marine reptiles. Yes.
Are they referring to like mosasaurs or plesiosaurs? Because these guys are distantly related to those. These are crocodile relatives.
It's hilarious how many different times reptiles went marine. Like I know.
Convergent.
Yeah, I like today you have let's see here, you have whales as among mammals. You have whales and you have seals. And arguably maybe sea otters. Yeah, sea otters. Yeah, arguably. Yeah, and those are the those are
manatees.
Oh yeah, manatees. Yes. Of course, yeah, manatees.
Yeah.
And also the extinct desmostylians as well. And you also have extinct sea sloths.
Right.
Even among mammals, you have like very, very many different times. But I think reptiles really take the cake. I cannot count how many times they have gone marine among reptiles. So many times. Yeah. And this is a good example of a convergent evolution. Yeah, you would be forgiven to mistake them for mosasaurs. They are not mosasaurs. Mosasaurs are actually lizards. They are within the group of lizards, and so are snakes. But these guys are closer to crocodilians, the ones that you see right now, like Plesiosuchus. Not Plesiosaurus. Plesiosaurus is a sauropteridian. Yes, right. Sauropteridian, right? That's the group that includes the plesiosaurs.
You're right. Yes, Sauropteridia.
Yeah.
Mhm.
Yeah. But Plesiosuchus is a crocodile relative. And also, ironically, you can see here Plesiosuchus is hunting down a plesiosaur. Yeah. But yeah. All right. Next slide. We will move on. All right, so now we go into a subgroup of crocodylomorphs called the Mesoeucrocodilia. The name essentially translates to middle true crocs. It's basically the before this you have another paraphyletic group called Mesosuchia, which is a midpoint between the Protosuchids and the Eusuchus. But now we have replaced this as by a monophyletic version of Mesosuchia. So now we call this group Mesoeucrocodilia. It's basically the same thing as that crustaceans are paraphyletic. Some crustaceans are more closely related to the insects than to other crustaceans. Right. So sometimes you can see researchers talking about the group Pancrustacea. Pancrustacea is basically the monophyletic version of Crustacea. So Pancrustacea includes crustaceans and also the insects. But here we have a similar thing happening. The Mesoeucrocodilians is the monophyletic version of Mesosuchia.
Yeah, it's like the Rhimipeds are like the closest crustacean quote group to the hexapods. And then there's the the Cephalocariida, I think, the little horseshoe shrimp, whatever those guys are.
Yeah. Do you know if are pillbugs or the roly-polies more closely related to the insects, or are they more closely related to the lobsters and crabs? I'm not sure.
Hold on. Let's see. That's Onicidia. Let's look. Onicidia. Survey said that's crabs and lobsters because they're in Melicostraca.
Yeah.
Yep. Oh, my unfinished journey for $2 says, "Don't be a dorky darkosaur, like and share instead." Very true. Insects are crustaceans. Yes, Smitty, that is correct.
Yes.
Because crustacea is paraphyletic. It doesn't include it. You don't traditionally think of crustaceans as
whenever I think about the situation like this, insects are crustaceans and ants and bees are wasps and snakes are lizards, I'm always thinking of that meme, it's always been like this. Yes, it always has been like this, with the two astronauts,
right,
and one pointing. I'm always thinking of that stupid meme.
It is a good meme.
Yeah, it's a good meme. Maybe a bit outdated by now, but yeah, I still like it. Did you find if the pillbugs are?
Yeah, they're in Melicostraca, which is the same group that has crabs and lobsters.
Right. Yeah. So they are still closer to the classical crustaceans. Yeah. All right. So moving on to this group, the Mesoeucrocodilians are characterized by the fusion of the frontal bones. So before, the frontal bones came in pairs, like you see that in Protosuchus. You can see the frontals colored red. They are now in pairs. But in an early member of the Mesoeucrocodilians, Cisosuchus, the frontals have fused into one bone. And also, interestingly, you also have a fused frontal, but your frontals were fused independently compared to the crocodilians. So yeah. Also, very much like you, the Mesocrocodilians also have a secondary palate. So something that and I'm also mentioned this before, but I will mention again. Secondary palate appeared in this case, and crocodilians also have a secondary palate. And this is something you don't see among reptiles. Like many reptiles, basically the inside of their nose. There's nothing in between the inside of the mouth and the inside of the nose, right? If I remember correctly, they don't have for reptiles or most reptiles.
Oh, I think you're right. Yeah, I believe you're correct.
Yeah. So they cannot eat and or they cannot chew and breathe at the same time. So
Right.
a palate is very necessary if you want to chew on food and breathe through your nose at the same time. Yeah. So and that's why many reptiles don't chew, but in the case of mammals they do chew, and in the case of crocodilians they use their secondary palate for a different reason. They hold their prey underwater and having a palate, it also allows them to not fill up their nose with water, basically. Yeah. So it's the palate is secondary palate is a shelf that forms from fused palatines. So now the inside of the nose is separated from the inside of the mouth. Mm-hmm. And you can see also some a ventral view of some skulls, and I highlighted the choana or the internal nasal openings in yellow. And you can also see some interesting trend. The inside of the internal nasal openings begin to move towards the back of the skull. So here you can see in Poposauroidea, the yellow internal nasal opening is all the way at the tip of the snout. And then over in more derived members of the Crocodylomorphs, and especially in the modern crocodilus, the internal nasal openings have moved all the way to the back of the skull. It's an interesting trend to see. All right, next slide. So one subgroup of the Mesocrocodilia is called the Metasuchia, translating to beyond crocs. But I would call them cool crocs, because like one some papers again also using like osteohistology, looking at the bones and trying to estimate if they were endothermic or not. And some researchers have pointed out that this is the point where the crocodilians or the ancestors of the crocodilians became ectothermic secondarily. Like we know in the previous last week, we noted that the ancestors of the crocodilians were probably endothermic or at least very metabolically active at high metabolic rates. But this is when they cooled down, basically. At least according to some papers that I found.
Okay.
Yeah. But also some other pseudosuchians, according to the same studies, some other pseudosuchians became secondarily endothermic, like the teleosauroids and the phytosaurs that we mentioned previously.
Mm-hmm.
So they become also endothermic. Again,
interesting.
If you want to know more about this particular thing, I include some citations there in the slide below. Yeah. So we will take this for granted and assume that the members of this group were now endothermic. It's also interesting to note that this group is the only group that includes surviving members that survived the end Cretaceous extinction event. Like all other crocodylomorphs did not survive the end Cretaceous extinction event. So if I were to make a guess, again, taking with a grain of salt, if I were to make a guess, then the reason why the many Metazoians survived the end Cretaceous is probably because they were endothermic, or sorry, ectothermic. They probably were able to last a famine much better than other crocodylomorphs. At least, again, that's my guess. Don't take my word for it. Do your just read the papers. All right, next slide. So a very neat group within the Metazoians are the Notosuchians, or the southern crocs. Again, an incredible diversity within this group. They were mostly land-dwelling croc relatives, and as the name suggests, they were primarily located on the southern continents of the Gondwana. But we also have a few members that were found on the northern continents as well. But they were primarily located on the southern continents. The oldest record are from the Cretaceous, from South America, and a potentially earlier record from the mid-Jurassic, from Madagascar. So there's some very patchy early history among them. We know them very well from the Cretaceous, but very rarely from the Jurassic. All right, next slide. So during the late Cretaceous, the Notosuchians are present on all continents, or all Gondwana continents and islands, except for Antarctica and Australia. But we also a few present in Europe and North America as well, as I mentioned before. So this is when the Notosuchian diversity peaked. And there's also one very interesting location within South America called the Paru Group Basin. This location preserves the ecology with the highest Notosuchian diversity. Like I highlighted that in orange on South America. We have a lot of Notosuchians known from this location. All right, next slide. But then, after the extinction event, the diversity went down significantly, but they still survived the end Cretaceous mass extinction event. So this also, again, they are not part of the modern crocodilians that we know today. They are a very early divergent offshoot, very early divergent member or relatives to the crocodilians.
That means Notosuchia 1, dinosaurs 0.
Yeah, exactly, yeah. So in the Paleocene, or in the Paleogene, the Notosuchians have reduced in distribution. So they were extinct in India and Madagascar, and fewer species present on each continent. So there are fewer present on Europe, and a few were also present in Africa, North America, but most were present in South America. So they were also more restricted to low latitudes as the world continued to cool down. Again, as I mentioned before, the Metazoians were probably endothermic, and the Notosuchians were also probably more endothermic. So this makes sense. As the Earth, like during the Cenozoic, the Earth cooled down significantly. So the Notosuchians were much more restricted to low latitude regions. All right, next slide. And then now we move on to the Miocene, very recently, between 20 and 5 million years ago. This is when the Notosuchians made their last stand. They became extinct on every other continent except for their last surviving members in South America until the mid-Miocene 11 million years ago. Again, not too long ago. The last surviving member only lived 11 million years ago in South America.
Yeah,
all right.
That's pretty recent.
Yeah. All right. Next slide. So this now we're moving within the Notosuchians, and again, there are so many different interesting forms to mention. So And also one thing to note is that the phylogeny of Notosuchia has changed drastically in the last decades. Even currently, there are some competing hypotheses on exactly what the phylogeny should be. But here I show some recent proposals just to have a discussion. So the phylogeny shown here mostly relies on the most comprehensive study to date by Nicol et al. 2021. And also using the there's also a recent paper by Liardi et al. 2024, which updates the nomenclature of these groups as well. All right, next slide. Can you go back to one slide previously? Sorry, I forgot something to mention. Like in the art that you show right there, that's from the Baru group formation that I mentioned before. This location preserves the most diverse, most ecologically diverse location regarding the Notosuchians. Yeah. All right. Next slide. Sorry about that. And here we have like one subgroup of Notosuchians called the Gracilisuchidae. Guess where they are from?
Is it Uruguay?
Yeah.
Yes, I got it right. I was worried for a minute there.
Yeah, and they include some very neat-looking members. You have like Erpetosuchus. One species of Erpetosuchus is also called the rat croc, because the Erpetosuchus ratoides has like the forward-pointing lower teeth, and you can see it in the if you look carefully in the depiction on the right, you can see the teeth on the lower jaw pointing forward like that. So they are called the rat croc, or nicknamed. And then below that you have the Aetosaurus, the crocodile. Yay, we found it. We finally found it. Crocodile. Do you have anything to note about the Aetosaurus and such? I think you have heard about.
I've heard
before,
of.
right? Yeah.
Yeah, I've heard of these guys in Erpetosuchus from the Eraripe formation that has a bunch of dinosaurs and pterosaurs and stuff. Yeah, I've heard of these guys. I don't know a whole lot about them. I've just heard of them.
Yeah. I'll also before I forget, the upper one, the upper Eraripesuchus is called the dog croc. Nicknamed, yeah. I've seen those nicknames as well. All right, so next slide. So now another terribly named group, the Mahajangasuchidae, and this includes the nicknamed hippocroc and the other nicknamed boar croc. And there's also one famous croc that you have seen before, the Caprosuchus. The old depiction depicts them as a land walking cock relative, but most recent studies says that they were probably semi-aquatic, like the depiction on the bottom right. So they probably looked more like that in the water. And also the other member, the Mahajangasuchus, is a very oddly shaped skull, and that's why they are called the hippocroc, because they have like and not very similar, but this I guess somebody thought it looked like a hippo, but still a pretty oddly shaped skull compared to the typical crocodilian skull that you are familiar with. All right, next slide. Or have you anything to note about the Caprosuchus, Jackson? Or maybe?
No, I don't think so.
All right. I think I've seen them before on like nature documentaries. I think Caprosuchus, if I remember correctly. I think I remember something on National Geographic about Caprosuchus, and I think if I remember correctly, they were depicted as a land-walking predator as well. I also remember something else. Are you familiar with the old British show Primeval, Jackson? Maybe or maybe not.
I mean, I'm aware of it. I never watched it.
Yeah, I that was a very old show, and I think I remember one episode that used Caprosuchus in that show as well. And
I've
again,
heard of
they
that, yeah.
and again they also use the terrestrial depiction of that as well. Yeah, but yeah, well, that's a one fun trivia to mention. All right, next slide. So now we have two families, Pyrosauridae and Aetosauria. Yeah, or the piercing crocs. There are two diverse families. Again, these include way more genera than I can show here. The recent paper that I mentioned before has updated the nomenclature of these families. So the names that I'm showing right there in the phylogeny are two different names. So they are like the family Pyrosauridae, or alternatively Pyrosauridae, and Aetosauria or Poposauroidea. They are the different names for the same Poposauroidea. Yeah.
Yeah,
Funny,
that's one
funny
of the
memes.
fun things. Right. That's one of the fun things about cladistics, right? Is some groups have been like swapped so many times. Members go in and out. They change their position, and it's like if it's a really old group, so it's got like 10 different names, like like the SAR group or TSAR or Chromista or Chromalveolata, or it's just so many different names for like not quite the same group, of course, but pretty close. So
Yeah, like the old name Poposauroidea. I hate this, but when I was looking up.
Oh, we switched.
Are you still? And I was like a little error, I believe. Oh no, never mind. But I was looking up online about Poposauroidea, and I found an artist depicting a croc in the as Pepe the Frog. Yeah, funny memes. Okay, but in any case, in a recent paper by Rubens et al. 2024, they described a new genus, and they also proposed that the Pyrosaurids are terrestrial, while the Aetosauchids are more semi-aquatic. And the reason for why they concluded is they decide the fact that the former has a high snout, while the latter has a narrow snout. And this is often the case. What happens in crocodylomorphs when they become semi-aquatic, the snout becomes more narrow relative to the ancestors. So that's maybe that's one reason why they concluded this. That one group was more terrestrial and the other group was more semi-aquatic. All right. Next slide. Okay. And here are a few more examples of.
Goodness gracious, that's like is like a name taken from like a native culture.
Yeah. I'm not going to try to pronounce that.
There's a hadrus. No, is it hadrus? No, it's not. It's an iguanodontian, I think, that has a crazy name like that.
Yeah. I wouldn't be surprised if they were named. Yeah, that somebody used a local name. Like they are often found in
here it is.
South
I found
America.
it.
Yeah.
Is it? No, it is it's a hadrosauroid. Yeah. Okay. Here I'll put the name in the chat. It's the name is comes from I think like a Mexican indigenous culture. Here we go. I have no idea how to pronounce that.
Who kan Canatlus. Canatlus. All right. Yeah. That's the best attempt I can make.
Yeah, it's crazy stuff. I don't know Nahuatl. And I have no idea how to pronounce that. So
I have also a name called the Quetzalcoatlus, but the only reason why I can pronounce it because it's I've heard that name pronounced so many times,
right,
by so many people, so I'm used to the pronunciation. Yeah. All right, so yeah, Yeah, we go to the next slide. So moving on, like one subgroup of the Notosuchians is called the Xiphosauria, translated to blade-toothed crocs. That's like you have, if I remember correctly, again, if Dapper were here, the resident linguist, he can correct me, but I believe the Xiphus is a name. I think it's a Greek name referring to like the double-edged blade that Greek soldiers used to use, the Xiphus, and they are named for that, the Xiphosauria. Yeah. At least if I remember the etymology correctly. Somebody else can correct me on this if possible. This name was originally used to refer to all crocodiliforms with such teeth, but now it has been given as more specific cladistic name or definition.
Because we use like Ziphiodont. That's
yeah.
Ziphiodont
is not a group; it's just more of a a trait, a condition.
The way the tooth looks.
Yeah.
Right.
Yeah. The way the tooth looks. Yeah. But Xiphosauria is just is now defined as a cladistic monophyletic group. Yeah.
Mm.
Mm-hmm. And so in this case, ironically, despite the blade teeth of these groups, the early members of this group includes herbivores like the cat croc, Paracrocodylomorpha. But there were also within Xiphosauria there were also some very large predators as well. And also one interesting to note is that you can see the skull image of Paracrocodylomorpha. You see a teeth that are almost like canines, and also teeth that are almost like molars or premolars, and also teeth that are like molars. So Paracrocodylomorpha was really, really mammal-like in regarding the teeth. Very interesting. So they almost evolved the same differentiated teeth as mammals in this regard.
That is interesting because reptilians are pretty well known to have pretty boring looking teeth.
Mm-hmm. Yeah, but not crocodilian relatives. They tried many different things in this case. Yeah. All right, next slide. Maybe we can. We are still like a few minutes to go. Maybe I can finish up the Notosuchians. So if you're finished with the Notosuchians, then we can. It's a good place to end it right there. Yeah.
Okay.
All right. So another interesting member of the Xiphosauchians is the Cymosuchus. Also a very neat-looking animal. This was one of the very, very heavily armored, pug-nosed croc. This is almost certainly a strictly herbivorous crocodylomorph. So again, perhaps in occasion it may have munched on something made of meat or something, but it's probably mostly herbivorous in this case. They have like maple leaf shaped teeth as well. Yeah, and they also made an appearance in Prehistoric Planet 2.
Yeah, they did.
Recent. Yeah. Mm-hmm. Neat cameo. Yeah. All right, next slide. And you also have a group called the Sphegasaurians, or the Slayer reptiles. Also a good name for this. But these were largely carnivorous or omnivorous. And one interesting member is called the Armadillosuchus, the most famous member, which has, as the name suggests, it had the armadillo-like armor around its back. You can see this. You can see the skeleton in the bottom left with the armor around. Yeah, and they also had pretty almost like a warthog teeth sticking out from the jaws, like a very large front teeth sticking out like that. And they probably use those to dig or for tubers or something like that. They're probably digging animals as well, making burrows and such. Living like armadillos. Yeah. All right, next slide. I some the paleo art from by GRC.
Mhm.
You can see some different sizes of the members of this group. Yeah. All right, next slide. And it's a good paleo art showing the lifestyle of Armadillosuchus. Again, probably lived in holes. It's dug up itself. All right, next slide. So now we come to interesting again the very carnivorous members of this group, the big predatory Notosuchians. You have two families, Paracrocodylomorpha and Sebacidae, and they include rather large land-dwelling predators as well. However, the relationship between these two is contested. There are two hypotheses. Like you have one hypothesis that proposes that the Paracrocodylomorpha and Sebacidae are close sisters to each other under the group Erpetosuchidae. Or alternatively, we also have the Sebacia hypothesis, which puts Sebacidae as sister to the Pyrosaurians. So a different placement of Sebacidae. So, but for now, I will assume that they are sister to the Paracrocodylomorpha. I think that's the most popular hypothesis, if I'm not mistaken. All right, next slide. And there's also one interesting recent discovery. This is as I mentioned before, Notosuchians are not very. They are well known from the early Cretaceous, but they are not well known from the Jurassic. And we have recently filled this gap with a recent species called the Razandandrogobi from Madagascar. Or at least I think it was discovered before, but it was reclassified as a Fasolasuchus and provisionally as a Sebacosuchian in 2016. If this is true, then this genus is currently the oldest and also the largest Notosuchian that we know so far. However, if this is true, you can see that there's still a lot of missing record from the Notosuchians in the Jurassic and early Cretaceous. So again, there's some gaps in the fossil record in this case. All right, next slide. So here's some example of the Paracrocodylomorpha or Paracrocodylomorpha. They are hypercarnivorous. And in South America, they compete against the Abelisauriid dinosaurs.
Interesting.
So they have very robust box-shaped skulls. They have a notch in the upper jaw, where a canine-like tooth fitted in. They also have, as I mentioned before, they have blade-like serrated teeth, like Komodo dragons as well. So they have. So the other family, the Sebacidae, also have these traits. So they are either convergent, according to one hypothesis, or if the Paracrocodylomorpha and the Sebacidae are sisters, then these traits are due to common ancestry. There's a debate on whether they are convergent or not. Yeah. And one genus survived a few million. One genus of the Paracrocodylomorpha survived a few million years past the end Cretaceous extinction event. So yeah. All right, next slide. So now we come to the Sebacidae. They are the most recent surviving lineage of the Notosuchians. They made it all the way until 11 million years ago.
Okay.
Yeah.
Pretty close.
Yeah, pretty close. Yeah. So they were also hypercarnivorous and included medium to very, very large sized carnivores. Like there's one that is like 6 meters or 20 feet in length called Paracrocodylomorpha. Paracrocodylomorpha was the largest land-walking predator during the Cenozoic era. The largest land-walking predator during the Cenozoic.
Okay.
Yeah. Like as I mentioned, most of the Notosuchians and also the Sebacidae, most of them are known from South America. But we also have found some in Europe during the Cenozoic as well.
That's pretty wild.
Yeah. And also, surprisingly, the ones to be found in Europe are also the largest land-walking predator on Europe during the Cenozoic. So they were the biggest predators running around during
That
that
is
time.
pretty crazy to think about.
Yeah. And and also one last trivia, as the name suggests, that the Sebekids are named after the Greek god Sobek. Yeah. All right.
It's just the largest carnivore.
Yeah.
That's crazy.
All right, next slide. We are technically speaking, we've run out of time, but the last few slides are just some paleo art that we will cover. Okay, some scale images for scale. You have the gigantic Paracrocodylomorpha right there, next to the human silhouette, just to get an idea of how big it is. All right, next slide. You also have some size comparisons between different large
with Richard
carnivores. Yeah, with Richard Owen, yes. So I believe the largest land walking predator today is the polar bear. You can see it on top left. You also have various other gigantic predators that are now extinct. Like you have a hyena relative, a gigantic short-faced bear, also saber-toothed cat, a terror bird, a hyenodont, which is an extinct relative of the carnivorans. You also have an extinct relative of the whale and plus hippo group, Androsarchus. And on the bottom you have the Sebekid Paracrocodylomorpha compared to the largest terrestrial lizard, the Megalania, that ever existed. Okay, Megalania is now extinct, of course. He also Megalania is a relative of the Komodo dragon, if I believe, right?
Yeah, I believe so.
Yeah. But as you can see, Paracrocodylomorpha outsized every single one of these as the largest land-walking predator during the Cenozoic. All right, next slide.
Large and in charge.
You have another good paleo art of a Sebekid walking alongside Notosuchidae of South America. All right, next slide. And Notosuchidae are an extinct ungulate related to the perissodactyls. So South America used to have a very unique set of animals that are no longer there. Like again, the Sebekids is one of them, and the Notosuchidae are also one of them. And if you know another extinct,
and they survived until not too long ago.
Yeah.
Like the Toxodon went extinct during the last ice age. So yeah, it was pretty close.
Yeah, pretty close. Yeah. So and here's another one, another unique extinct ungulate. They are an Astrapothere, not an elephant. They look like elephants, but they're not elephants. And you see it hunting down by Paracrocodylomorpha in South America. All right, next slide. This is where we will cut it. But now we have finished up the Notosuchians, and now we will move on to later. We will move on with the Neosuchians. All right.
Okay. All right.
The good place
Peter,
to finish. Yeah.
All right. Pretty cool. All right. Well, thank you so much, Nesslig, for the presentation today. We will pick this up next week, and we will get the news.
Before I sorry, somebody corrected me, like Thylaco Leon Kennedy corrected me by mentioning that the Sobek is not the Greek god, it's an Egyptian god. I was mistaken with that. Yeah, it's not.
Sorry, I didn't catch. I saw the Egyptian garb. I guess I didn't process you saying that. I'm sorry.
Yeah, I mistakenly said Greek god for some reason. Like I don't know why. Yeah, it's an Egyptian god. Yeah, Sobek.
It does. Funny enough, Smitty. Yeah, the Astrapotheres, or some of them, did look like tapirs, and they actually were like kind of closely related to the group that has tapirs. I mean, like the Notosuchidae are like pretty close to the perissodactyls. So
yeah.
So yeah. So anyway, okay. Well, that was cool. We'll pick this up next week, and we will see. Or thank you everybody for coming, and we will see all of you next time. So bye, everybody.